Hi, so in this set we have a new game show on TV has 100 boxes numbered 1 to 100 in a row, each containing a mystery prize. The prizes are items of different types ABC in decreasing order of value. The most expensive type is of type A, which is a diamond ring, and there is exactly one of these. You are also told that the number of items at least doubles as you move on to the next type. For example, it's given that the number of items of type A is 1. The number of items of type B should be either equal to or greater than twice of A. That's what it is given. Okay? Number of items at least double. So B will be at least twice of A or more than A. C will again be at least twice of B, equal to twice of B or more than twice of B. D will be greater than or equal to twice of C and so on, right? And the sum of all these types should be 100. Okay? The total number of boxes that we have are 100. Each box has exactly one item. So the total number of items of all types together is 100. Okay? Let's look at the questions now. The first question is we have to minimize the possible number of different prizes. So for type A, to minimize the possible number of different types, we will try to take maximum of each type, maximum possible items of each type. ठीक है? Types maximize करने हैं तो हर type types minimize करने हैं, कम से कम करने हैं तो हर type के आप ज़्यादा से ज़्यादा prizes या items लो. So type A, it's given that there is exactly one of these, so we cannot maximize or minimize this. This is what it is. So we'll need at least one more type. Now type B, what is the maximum number of items of type B? So out of 100 total, we already have one over here. So we have 99 remaining items. Out of 99 items, B can have how many of those? Can B have all 99? Well, yes, there is a restriction on minimum number of type B. Minimum of type B should be 2. It cannot be less than 2, twice of 1. But there is no restriction on maximum value of a particular type. So the maximum value of type B can be 99. So we have total 100 and the minimum number of type of items is 2. So the answer here is 2. Okay. Next, we have to maximize the possible number of different types of items. To maximize possible number of types, we try to minimize the number of items of each type. So let's start with A. There is exactly one of type A. Now type B. To maximize the number of the types of items, we minimize the value of each type. So B will be minimum twice of A, which is 2. Okay? Minimum value of C will be twice of 2, 4. Then you'll have D, minimum is 8. So let's see how many items do we have so far. 3 plus 4, 7, 7 plus 8, 15. We need to reach 100. So 15, E will be minimum 16. So 15 plus 16 is 31. We can go ahead with one more type. F is 32. So 31 plus 32 so far is 63. So far we have 63 items. Now can we have one more item G? Now if we take one more item, this has to be minimum twice of 32, 64. But then 3 plus 64 becomes 127 items, but we have only 100 items. So this is not possible. Another type is not possible. So we had total 63 items out of 100. So we have 37 remaining. So let's do one thing. Let's give this 37 to F only. So for F, there are total 69 items and the remaining together are 31 items. Hence, we have total 100 items and the maximum number of types in this case will be 6. Fine. Moving on to the next question. Here we have which of the following is not possible. Okay, so we'll have to check each option one by one. Which of these is not possible? So let's start with the first option. There are exactly 30 types of B. So we have type A and type B. Type A is 1, type B is 30. So we have total 31. Remaining is 69. So if we assume all 69 of type C, is this case possible? Yes. 30 is more than or equal to twice of 1. 69 is more than or equal to twice of 30. So this is possible. Check. Next, option B, there are exactly 75 of type E. So we have A, B, C, D till E at least, and there are 75 of type E. Now 75 out of 100 is a big number. So what we'll have to do is, first of all, we'll have to minimize the number of items with the other types. So with A there is exactly 1, so B should be at least 2, minimum 2, C should be minimum 4 and D should be minimum 8. So how many items do we have so far? This is 15 plus 75, 90. So we have 10 more items remaining. So let's distribute all the 10 items to D. Okay, so D becomes 18 items. So the total that we get is 100 here so far, right? And if you look at B, that is at least twice of A, C is also at least twice of B, D is at least twice of C, and E is also at least twice of D. So all the conditions are satisfied. Total is 100 and each type is more than equal to twice of previous type. So this is also possible. Okay? Let's look at option C. There are exactly 60 items of type D. So we have A, B, C, D. Can there be exactly 60 of type D? Well, 60 again is a big number, right? Out of total 100. So let's first of all minimize the other items. So this becomes total 67. This is total 67. So we have another 33 items to be distributed. Can we have one more type with 33 items? No. Another type should be twice of 60 at least. So that's not possible. So this 33 will have to be distributed in between B and C itself. So what is the maximum value C can have? C can have a maximum value of half of D, which is 30. Okay. So now total we have 60 plus 30, 90, 90 plus 3, 97. So we have to distribute, sorry, not 97, 93. So we have to distribute 7 more now. So these 7 can be given to B. Let's say B is now 9. Okay. So now we have total 1 plus 9, 10 plus 30, 40, 40 plus 60, 100 items. So that is one condition satisfied. And second condition, each type is at least twice of the previous type. 9 is more than equal to twice of 1. 30 is more than equal to twice of 9 and 60 is more than or equal to twice of 30. So all the two conditions are satisfied. So this is also possible. Okay? Let's look at option D now. So if these three are possible, option D definitely would be your answer. But still let's check. There are exactly 45 items of type C. So we have A, B, C, D. Can there be exactly 45 of type C? Okay. Now is it possible to have another type? If at all? Well, if you have another type after C which has 45 items, you'll need at least 90 items of type D. But then total items will become more than 100. So definitely there will be no other type. There will be exactly 3 types, A, B and C. Okay. Now if C is 45, what is the maximum value D can have? D can have a maximum value of 22, less than or equal to half of C. So half of this is 22.5. So B can be maximum 22 and A we know is definitely 1. So with just the 3 of these types where C is 45, the total number of items that we can have is 23 plus 45, which is 68. But we want 100 items. We still have 32 remaining items. With 32 remaining items, we cannot have a different category and we cannot give any more items to A or B. A is fixed 1, B can be maximum 22 for this condition. So here we are not getting a total of 100 items. Hence this case is not possible. That's why option D is the correct answer. Okay. And now finally moving on to the last question. You ask for the type of item in box 45. So box 45. What is the type of item in box 45? So instead of being given a direct answer, you are told that there are 31 of these types in box 1 to 45. No, 1 to 44. There are 31 items of a particular type in box number 1 to 44. Box 45, which is just one box, definitely has the same item. And in boxes 46 to 100, there are 43 items of the same type. Okay. So whatever this type is, let's call this as type X. This type X has a total of how many items? 31 plus 1 is 32. 32 plus 43 is 75. So there are 75 items of a particular type. Okay. Fine. So if there are 75 types of items of a particular type, then what is the maximum number of different types of items? Okay, so we have to maximize the number of different types of items. So let's start with A. A definitely will have one item. So let's say this is the last type. We'll have few more types in between, and this is the last type. So let's see how many more types can we fit between A and X. So we'll have type B, which will be at least 2. Now this is a very big number, right? 75 out of 100. To maximize the number of types, we will minimize the number of items with each of the remaining types. So with B, we will assume that it is the least possible value 2. C will be least possible value 4. D will be least possible value 8. So far we have 1 plus 2, 3. 3 plus 4 is 7. 7 plus 8 is 15. 15 plus 75 is 90. So we have 10 more items remaining. Now can we have one more category over here, E, with 10 more items? No. Twice of 8, this has to be at least 16. So there cannot be one more category. Can we have one more category over here? No. If X is 75, next category will be 150 minimum. Then the total will become more than 100. So that's also not possible. Okay? So the maximum number of categories that you can fit is 4 plus this unknown category. So this unknown category will be E in that case, basically, right? So the total sum that we have so far is 90. So we need to distribute 10 more. So giving 10 more to D. Now the total number of items is 100, right? And each type is at least twice of the previous type. Fine. So the maximum number of items that you can have such that there are 75 of one particular type is option A. There are maximum 5 types of items. Okay. So that's it for this set. Thank you.